Okay, so 4.6 day 2 is a slight review of yesterday plus adding a little bit more because we never talked about cosecant, secant, or cotangent. So just to make sure we understand what we learned in the first lesson, it says rewrite each trig function in inverse trig function form. So what's the inverse of cosine? It's cosine inverse. So means that cosine inverse of root 3 over 2, right? Cosine inverse of this is pi over 6. Okay? So this means that tangent inverse of root 3 is, and I'm not going to put 60, I'm going to put pi over 3 because we always have to write our answer in radian. Rewrite each inverse function in trig form. So this means that if sine inverse of negative 1/2 is pi over 6, this means that the sine of negative pi over 6 is negative 1/2. And if the cosine inverse of negative root 3 over 2 is 5 pi over 6, that's because the cosine of 5 pi over 6 is negative root 3 over 2. Okay? All right, so for inverses, secant and cosecant have the same range as cosine and sine. Now, we're not doing cotangent. We took it out a few years ago because cotangent's inverse is tangent, cotangent's reciprocal is tangent. And tangent inverse is only defined in the first and fourth quadrant. And cotangent inverse is the first and second. And that was the confusing part for people. So if people just memorize that, it'd be easy. But we also want to justify it. So instead, we just don't ask anything about it. Okay, so just realize we're only doing secant and cosecant. So let's first talk about secant. Secant's reciprocal is cosine. And where is cosine defined? Cosine inverse, that is. 1 and 2. So that means secant inverse is defined in quadrants 1 and 2 also. If it's a positive value, that's the first quadrant. If it's a negative value, that's the second quadrant. Cosecant is the inverse of sine. Where is sine defined? That's quadrants 1 and 4. So that means cosecant, if it's positive, it'll be in the first quadrant. If it's negative, it'll be in the second quadrant. Okay, so let's try a couple of these. It's a review basically of yesterday, okay? It says secant inverse of 2. So I'm looking for the angle that has a secant of 2. And then I say to myself, I don't have secants memorized. So what you can realize is that secant inverse, I can change it to cosine inverse, which is its reciprocal. But then I have to take the reciprocal of 2. The reciprocal of 2 is 1/2. So instead, what I'm going to do is I'm going to pretend it said cosine inverse of 1/2. And I can do that. Cosine inverse is defined in the first and second quadrant. Where is it positive? Because 1/2 is positive. It's positive in the first quadrant. Is cosine x or y? It's x. So what angle has an x value of 1/2? Most of you think degrees right away. That's 60 degrees. But remember, our answer has to be in radians. So our answer is pi over 3. All right, let's try another one. Cosecant inverse of root 2. So once again, I want to know an angle that has a cosecant of root 2. And then I say, I don't have cosecants memorized. So I'm going to say, okay, well, instead, I'm going to change it to sine inverse, but I have to take the reciprocal. So I need the reciprocal of root 2. The reciprocal of root 2 is 1 over root 2. But then I have to rationalize that because this is root 2 over 1, right? So multiply root 2 over 2. I get root 2 over 2. So this is the same thing as sine inverse of root 2 over 2, which I can do. So I say to myself, which two quadrants is sine inverse defined in? 1 and 4. Where is sine positive? Because of the root 2 over 2 is positive. First quadrant. Sine is my y value. So I want to know what is that angle. That's my 45-degree reference angle, which is pi over 4. All right, next one. Arcsecant of negative 1. I say to myself, I don't have secants memorized, so I'm going to change it to cosine instead. So instead of writing arc cosine, I just like writing cosine inverse. I prefer inverse. Okay, so now I need the reciprocal of negative 1 since I took the reciprocal of secant. The reciprocal of negative 1 over 1 is 1 over negative 1, which is still negative 1. So I can do that now. So now I say, okay, where's cosine inverse defined? Quadrant 1 and quadrant 2. All right, where is it negative? In the second quadrant, but then I realize cosine's my x value, and that's not in my second quadrant. That's a quadrantal. So I want to know what quadrantal. So I'll write down my ordered pairs. This is negative 1, 0. This is 0, 1. And this is 1, 0. So where is my x value, negative 1? Right here. And what's that angle? Now, people will be like 180 degrees. Remember, it has to be in radians. So the answer is pi. All right, last one. Arc cosecant of negative 2. I don't have cosecants memorized, so I'm going to take the reciprocal, which is sine inverse. And then I'll take the reciprocal of negative 2, which is negative 1/2. All right, sine inverse is defined in my first and fourth quadrant. It's negative in the second quadrant. So this is going to be a negative answer. Okay, remember, I have negative angles in my fourth quadrant. Okay, so now I want to know what angle that is. Sine is the y value. So that is my 30-degree reference angle, which is pi over 6. So this is negative pi over 6. So one thing I want you to notice is that inverses, I meant to highlight, inverses find you angles. Inverses find you angles. So if I'm asking you for an inverse, I'm asking you for an angle. Okay? All right, next it says use the calculator to approximate the values of each expression. So I want you to realize that there's no cosecant inverse button. So you have to use the reciprocal, which is sine inverse. And then I have to take the reciprocal of 5, which is 1/5. So I'm going to do sine inverse of 1/5. Let me bring up my calculator here. I know. Here we go. Sine inverse of 1/5. So second sine, 1 divided by 5, close the parentheses at enter, and I get 0.201. 0.201. Okay. Once again, I don't have a secant inverse button, but I do have a cosine inverse button, which is the reciprocal. So I have to take the reciprocal of negative 3, which is negative 1/3. So I'm going to do cosine inverse of negative 1/3. Negative 1 divided by 3, close it, enter. Oops, I meant to enter and I hit graph. Oh, and then I erased it. Negative 1 divided by 3, enter. 1.911. All right, 1.911, 1.911, 1.911, and there's that answer. Okay, this time notice I remember to put the directions in around to the nearest thousandth. Okay, so next it says find the exact value of each expression. Now, some of these, there's more than one way to do it. I always do it the same way because I'm not going to lose anybody, okay, or at least I hope not to lose anyone that way. So we're going to try to do these the same way every single time. So first off, let's think about if our answer is an angle, okay? The answer here is not an angle. This is an angle, but then we're taking the secant of that angle. So if we're taking the secant of that angle, we need to do secant's the reciprocal of cosine, so it would be hypotenuse over adjacent. So please realize that I also have to draw a triangle for this, okay? So we're going to start by looking at the inside here, like we had tangent inverse of 1/2. So let's do that first. So I want to say to myself, okay, which two quadrants is tangent inverse defined in? It is defined in the first and the fourth quadrant. So I'm going to start off by drawing that. Now I'm going to say, okay, that's 1/2 is a positive number. Where is tangent positive? That's the first quadrant. So I know my angle's in there. Okay, and this is my angle right here, which I'll just put a theta right there for a second. Okay, now if I say, okay, what angle has a tangent of 1/2, I should hear blink. I should hear nothing. I should get blink stares because we don't have that one memorized, right? That does not mean we need a calculator. It just means that we're going to have to make a triangle here. So I'm going to make this into a right triangle by dropping a vertical line to my x-axis. This is opposite. This is adjacent because that's what tangent is. So 1, 2. I need to find my third side using Pythagorean Theorem. 1 squared plus 2 squared equals x squared. That's 1 plus 4 equals x squared. 5 equals x squared, and then square root plus or minus, square root plus or minus. So I have x equals positive or negative root 5, and now I have to decide which one it is. Hypotenuses are always positive, so root 5. All right, so you might be saying, oh, I've done this before, but the good news is that this is actually way less work than finding the remaining trig functions. I only need secant. So I want to know what secant of theta is. Okay, so remember, secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So I just need to put the hypotenuse, which is root 5, over the adjacent side, which is 2. And there's my answer. Root 5 over 2. All right, let's try another one here. So once again, I'm going to do the inside first. Is my answer an angle? No. If my answer is not an angle, I want to draw a picture. Okay, so I'm going to start by drawing this. All right, cosine inverse. Our cosine, which two quadrants is cosine inverse defined in? 1 and 2. Which one is it negative in? Because it's negative root 7 over 3. 2. My angle theta is always created by the radius in my x-axis, so that's theta. Do I know an angle that has a cosine of negative root 7 over 3? No. So I'm going to make this into a triangle. All right, adjacent is negative root 7. Hypotenuse is 3. So I need to find my third side. Pythagorean Theorem, negative root 7 squared plus x squared equals 3 squared. That's 7, because remember those cancel each other out. Plus x squared equals 9. Subtract 7. X squared equals 2. And then square root plus or minus. Square root plus or minus. So it's either going to be positive 2 or negative 2. Since it's up, it's positive 2. Okay, so now I'm going to look to see what I need. I need cotangent. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. So this is adjacent over opposite. So cotangent of theta is adjacent, which is negative root 7. So I'm going to put the negative in front, over opposite, which is root 2. I can't leave my answer like that because it's not rationalized. So I'm going to rationalize by multiplying by root 2 over root 2. And I get negative root 7 times root 2 is root 14 over root 2 times root 2 is 2. If I could simplify negative root 14, I would, but I can't because there is no perfect square that goes in there. All right, next one, I'm going to start with the inside, and I'm going to draw this. I'm going to draw it into a triangle, and then I'll take the tangent. So my answer is going to be opposite over adjacent once I have my triangle drawn. Now, cosecant I don't have memorized. So I'm going to say, all right, well, what's the reciprocal of cosecant? It's sine. So I'm going to do sine inverse of, and then flip negative 2. Sorry, find the reciprocal of negative 2, which is negative 1/2. So that's what I'm going to start off by drawing. Sine inverse is defined in my first and my fourth quadrant. It's negative in my fourth quadrant. I need to find this angle and then find the opposite side over the adjacent side. But first, I need to label what I have. I have the opposite and the hypotenuse. The opposite side is 1. The hypotenuse is 2. Which one's negative? This is down 1. Right? And the hypotenuse can never be negative. All right, Pythagorean Theorem to find my third side. I have negative 1 squared plus x squared equals 2 squared. So I have 1 plus x squared is equal to 4. So I have x squared is equal to 3. And then square root plus or minus, square root plus or minus. This is to the right, so it's positive root 3. All right, now I'm ready to find the tangent. Tangent of my angle is the opposite side, which is negative 1. I'll put the negative in front, over the adjacent side, which is root 3. I need to rationalize that. So I'm going to multiply by root 3 over root 3, and I get the tangent of that angle is negative root 3 over 3. So this is one of them that had more than one way to do it, because what you could have done instead, let me show you instead really quickly. You could have said, I do know an angle that has a sine of negative 1/2. It's in my fourth quadrant. That is root 3 over 2 negative 1/2, so it's a 30-degree reference angle. So this is negative pi over 6. Then I could take the tangent of negative pi over 6. So I need to know the tangent of pi over 6, which is root 3 over 3, because it's a 30-degree reference angle. But remember, it's in the fourth quadrant. All students take calculus. Tangent's negative there. So there's another way to do that one. But I tend to not do it that way. All right, next one. I'm going to do this first. I'll draw that triangle, and then I'll take the sine. So I'll end up needing opposite over hypotenuse. All right. Secant inverse, no clue. So I'm going to do cosine inverse instead. The reciprocal is 2 over 3. All right, where's cosine inverse defined? The first and second quadrant. Where is it positive? The first quadrant. Make my right triangle. Here's theta. Adjacent is 2. Hypotenuse is 3. Pythagorean theorem to get my third side. So I have 4 plus x squared equals 9. X squared is equal to 5. Square root plus or minus. Square root plus or minus. So root 5 or negative root 5. This is up, so root 5. All right, now I need to find the sine of that angle. So the sine of theta is equal to the opposite side, which is root 5, over the hypotenuse, which is 3. And that one's done. No need to rationalize because there's no radical in the denominator. Okay, so I have 4 more that you can start to try on your own, but I'm going to do them also. But if you want to pause the video and then unpause it to check your answers, you can. All right, if you're checking your answers, A is 2 root 3 over 3. B is 12 over 13. C is 2 root 14 over 9. And D is 3/4. So if you got stuck on any of them, you can watch that part of the video. If you would like to do them all with me, you can do them all with me. Okay, find the exact value of each. So I'm going to start with this inside right here. Is my answer going to be an angle? No, because I have to take the secant of that. Secant is the reciprocal of cosine. Cosine's adjacent over hypotenuse, so this is going to be hypotenuse over adjacent. All right, I'm going to draw this first. Sine inverse is defined in my first and my fourth quadrant. It's negative in my fourth. Here's my triangle. Opposite is -1. Hypotenuse is 2. Pythagorean theorem, -1 squared plus x squared equals 2 squared. 1 plus x squared equals 4. X squared is 3. Square root plus or minus. Square root plus or minus. It's to the right, so it's positive root 3. Then I need secant, which is, secant of theta is hypotenuse, which is 2, over adjacent, which is root 3. And then I have to rationalize by multiplying by root 3 over root 3. So I get the secant of that angle is 2 root 3 over 3. All right, B. Once again, this I'm going to draw this angle, make it into a triangle so that I can find the cosine, which is adjacent over hypotenuse. All right, tangents defined in my first and fourth quadrant. It's positive in my first quadrant. Here's theta, my angle. Tangent's opposite, which is 5, over adjacent, which is 12. I could do Pythagorean theorem, but I know that that is a Pythagorean triple, 5, 12, 13. So if you did Pythagorean theorem and you got the square root of 169, which is 13, that's fine. Now I need to do cosine, which is adjacent over hypotenuse. So cosine of that angle, the adjacent side's 12, the hypotenuse is 13, so 12 over 13. All right, next one, I'm going to do this first, okay, and then I'll take the sine, which is the opposite side, over the hypotenuse. Secant, I'm not familiar with, so I'm going to take the reciprocal, which is cosine inverse. So cosine inverse is, and then the reciprocal of -9/5 is -5/9. All right, cosine inverse is defined in the first and the second quadrant. It's negative in the second quadrant, so my triangle is in the second quadrant. Here's theta. Cosine is adjacent, which is left 5 over hypotenuse. Hypotenuses are always positive. I need to do Pythagorean theorem to find my third side. This is not a triple. So I have 25 plus x squared is equal to 81. Subtract 25 from both sides. I get x squared is equal to 56. Square root plus or minus. Square root plus or minus. X equals plus or minus, and I'm not going to leave it as root 56 because perfect squares go in there. Well, a perfect square goes in there. 4 goes in there 14 times. Square root of 4 is 2, so this is plus or minus 2 root 14. Since it's up, it's positive 2 root 14. All right, now I just need the sine of that angle. Sine is the opposite side, which is 2 root 14, over the hypotenuse, which is 9. All right, last one. Start with this right here. I'm going to end up doing cotangent, which is adjacent over opposite. Cosine inverse is defined in the first and the second quadrant. It's positive in the first. There's my angle, theta. Adjacent is 3, hypotenuse is 5. Once again, you can do the Pythagorean theorem, but I realize this is a 3, 4, 5 triangle. Also 4 is positive because it's up. I should have paid attention to that for this 12 one right here too. It's to the right, so it's positive. All right, now I can do cotangent, which is cotangent of theta, my angle that I drew. Adjacent side, which is 3, over the opposite, which is 4, so 3/4. All right, hopefully you did pretty good on that. Number 5 says simplify this expression. So this has x left in it, but it's the same idea. So you're going to draw this triangle, and then you're going to take cosecant. Remember, cosecant is reciprocal of sine. Sine is opposite over hypotenuse. So I'm going to do hypotenuse over opposite. All right, cosine inverse is defined in my first and second quadrant. It's positive in my first quadrant. All right, cosine is adjacent, which is x, over hypotenuse, which is 3. I need to find my third side. Now, I don't want to call my third, I need to find this third side right here, right? I'm going to call it b instead of x because x is in this problem. So I'm going to do x squared plus b squared equals 3 squared. X squared plus b squared equals 9. And then remember what you're solving for. You're solving for b. So I'm going to subtract x squared from both sides. So I have b squared equals 9 minus x squared. And now I can square it to solve. Square root plus or minus, square root plus or minus. It's up, so it's positive, square root of 9 minus x squared. Okay. The last thing I have to do, here's theta right here. I have to do hypotenuse over opposite. Hypotenuse is 3 over the opposite, which is the square root of 9 minus x squared. And we're not going to make you rationalize that because it's not what I'm trying to teach right now. Okay, last set, we're going to move back over to this. This is more review of what we just, well, not what we just learned 5 minutes ago, but what we learned in 4.6. Find the exact value of each expression. So first off, let's look at all 8 of these real quick. What does your answer look like? So when I ask you that, you should be asking yourself, is my answer an angle? So is this an angle? Yes, because you're not finding the angle and then taking the cosine or then taking the sine or then taking the tangent. You're just doing that. So your answers are all angles. If it's sine inverse or tangent inverse, your answer has to be in between negative pi over 2 and positive pi over 2. And if it's cosine inverse, your answer has to be in between 0 and pi. All right, cosine inverse, which 2 quadrants is it defined in? 1 and 2. Where is it positive? First. Cosine is your x value. So what is this angle right here? It's pi over 3. All right, next one, cosine inverse, 1 and 2. It's negative in the second. Cosine's my x value. What is this angle? Now, that is another 60-degree reference angle, right? But it's in my second quadrant. So remember I wanted in radians. What's my pi over 3 angle in my second quadrant? 2 pi over 3. Remember, cosine inverse answers are never negative. So if you're like, why isn't it negative pi over 3? Because it's not in this quadrant right here. All right, next one, sine inverse of 1/2. Sine inverse is defined in your first and second quadrant. It's positive in your first quadrant. Sine is your y value. So what is that angle? That's 30 degrees, but we want it in radians, so pi over 6. Sine is defined in your first and your fourth quadrant. It's negative in the fourth. Sine is your y value. What's that angle? This is 30 degrees right here, but remember this one's negative, so this is negative pi over 6. Last 4, we have 2 tangent inverse and then a secant inverse and a cosecant inverse. So tangent is defined in the first and the first and the fourth quadrant. It's positive in my first quadrant. Remember, tangents you have memorized. What angle has a tangent of root 3? Pi over 3. Tangent inverse is defined in the first and fourth quadrant. It's negative in the fourth. What angle has a tangent of root 3? Pi over 3. But remember, this is in a negative direction. So this is negative pi over 3. Secant inverse, I don't know what quadrant. I shouldn't say I don't know, but the way it looks, it doesn't pop into my head. So I say, okay, I'm going to change it to its reciprocal, which is cosine inverse. Then I have to take the reciprocal of root 2, which is 1 over root 2, which rationalizes to root 2 over root 2. Cosine inverse is defined in the first and second quadrant. It's positive in the first. Cosine is my x value. So what angle is this? Pi over 4. Once again, I have one that I don't recognize, so I'm going to say, okay, I know the reciprocal is sine inverse, but I have to take the reciprocal of -1, which is -1. Sine inverse is defined in my first and my fourth quadrant. So now I want to know what angle has a y value of -1. That is not in a quadrant, that's a quadrantal. This point right here is over 0 down 1, where the y value is -1. So what angle is this? Remember, it's a negative angle right here, which is -pi over 2.